So we are going to continue with regular expressions area. We are going to talk about more things that regularly happen with regular expressions. A lot of different syntax also we're gonna see about how Perl take cares of things in general. So substitution is a very important topic in regular expressions, because what we saw so far is how we can substitute regular expressions with a string. But in substitution here, what we are gonna do, we are gonna pull out part of a string and we match it in particular pattern. Then we are going to rip out that string and replace it with another string. It's very nice way of working on it. So usually the typical format of the substitution is the following. The first line, s/old/new. We are saying take a new sentence and match it with the regular expression that is in old and replace it with it. Okay, so the first example we have in the $_ the following text. He is out bowling with Barney tonight. The second line, what we are doing, we are saying whenever you see a string of Fred, replace Barney with that string. Okay, so I'm going up. He is out bowling with Barney. So we found the old string and we are going to replace it with Fred. So it will be he is out bowling with Fred tonight. So when I print out this sentence, this is what will be. Now, what I have to mention also, if the match didn't happen, like if the match failed, the word Barney didn't exist in my string, nothing will happen actually, because usually the value that is turned, either the match happened true or didn't happen false. So your code will be continuing as it is. There is no problem of not matching. Now how about just describing what's happening in Fred? You have to remember that the right hand side of this expression, of this sentence, is a string. So if I have double quotes over there, whatever we learned that we can use with double quote, like /n/t, variables with $, 1 or 2 or 3, the memory variables, if you remember the back references, can be used as well. So this is the second example here. So what we are doing here, we are saying, okay, I have an old sentence, so s/ with space, then open parenthesis, saying any word appears. So here I am trying to match with space and any consequence of words with another sentence against space $1's team. Now what can I have with $1? It's a memory, so whatever is inside the parenthesis saved will be in that $1. So in our case, let's say we implemented the first example. So now we have he is out bowling with Fred tonight. What will happen will match with Fred. This is the exact, because as you remember, the words are any character, digits or underscore. Space is not included with W. So here we'll match with Barney. We'll take off that sentence from the string and we'll replace it with against what is in $1. Okay, it's what inside the parentheses, which is Fred. So against Fred's team. So the end output will be he is out bowling against Fred's team, and we'll print out this for us. So the last part of this slide, I am saying that in general any substitution that starts with s// return replacement that is needed. Okay, as you can see here, I have a string of Fred Flintstone, and then I am saying if s/Fred/Wilma, what will happen? We'll replace every Fred with Wilma in this case. So if that statement was implemented, or it found a match, and in our case we found a match, which is Fred. We replaced it with Wilma, so the result of if is true. So I can use it as a statement of if to execute code after it. So if I'm saying if the match happened here and the return value is true, do the following code inside the block, the open brace, the close brace. Now if it doesn't happen, also I can put it in else statement, so I can already work on my code based on the output of that statement. Global changes. The global changes is really important because sometimes you don't want to substitute only one word. So in our example here, when we match with the first one, when we match with Barney, if Barney appears more than once in that string, only the first one will be matched, will not work on the whole string. Now if I have the following, home sweet home, and I want to replace both of them, there is a way by adding /g at the end of your substitute string. So s/home/cave/g will work on the whole text and will return back cave, sweet cave. So replace both home whenever home is repeating. So G, it says make it a global, make the changes all over the place. Now where I can use this one and can be very useful, let's say you have a complete file that has a text, that it has combinations of strings, of spaces, of tabs, of new lines, of random number of spaces. So if you want to really to make your text more coherent, and you have a canonical white spaces, all of them white space, single white space, I can use the following code: s/\s plus /space/g semicolon. What I am saying here, that whenever you see one space or more, which could be a tab, could be new line, wherever you see spaces, replace it with single space. So here I can see my token separated by spaces. Also I should mention that, which is the last statement here, that I can use whatever we learned before in our with our substitution. I can make it case insensitive by using the I can use it to make it readable by adding comments, for example, in my expression, in my substitution, by using X, or I can use it with S for the spaces. Whatever you want to do, you can use it with it. Okay, what kind of alternative delimiters? We saw something similar to that previously. Here we're going to use it on the substitution. So like we said before in the quoted word, that we can use any kind of delimiters, paired delimiters, or unpaired delimiters. We can use it with the M. So instead of using just a slash, we can substitute it with the same like we did with the M. So here, for example, the first example down, I want to substitute HTTPS that appears at the beginning of the string with HTTP : HTTPS : with HTTP : I am using the pound sign here as delimiter, because if you think about it, if I'm gonna use the slash inside my expression and my substitution phrase, I will have to follow every to precede every slash with backslash to be understood as a typical slash. So in this case, I would rather use a pound instead, and a lot of programmers in Perl use a pound or the curly braces that you see at the end. Also, you can use combinations of delimiter, like the second code here. So less than, bigger than, this is one delimiter, paired delimiters, the other one pound and pound. But don't do that, because really you're going to confuse whoever is going to read your code. Case shifting. Now, how about the uppercase and lowercase. How can we manage our code to substitute some specific type of cases that we have, uppercase, lowercase, or mixed cases even? So this is the first example. I have in the $_ the string I saw Barney was afraid. Now what I am doing, I am saying whenever you see, on here you have to remember I'm using parentheses, so I am activating the $1 memory variable. So I'm saying here whenever I am seeing a word Fred or Barney, then I am following it with a new string. The new string will be in $1, but I have a /u in front of it, which means make it all capital. So in this case, I saw Barney. Barney, only the first letter is capital, but by putting the upper U will make it all capital. So B will be capital, A will be capital, R will be capital, N will be capital, E will be capital, and Y will be capital. Now because I follow it with a /GI, I'm saying even if it's mixed case insensitive I, and G, repeat it to the end of the phrase. So here that means if when Fred appears also it's a match, so we'll replace Fred with uppercase as well. All the letters in Fred will be uppercase. The opposite of a /u is a /L. Now if I want the third one to have my case shifting continue until specific area, I can stop it by using \E, or that can be stopped by the end of the replacement, like if there is no match anymore. So in this example, what I am saying, okay, find me a bunch of words, then followed by a space, and with followed by a space and another word. So if I am matching up, that means I am searching. The first memory will have Barney, then with, then I have a Fred in the second memory. I am following it with \U, that means capital, for whom you have to make sure capital will be applied at what will be applied on the second memory. In our case, our second memory is a Fred, so only Fred will be all uppercase. Then I'm saying stop it by E, don't continue doing any match further. Then print with, and the first one, the first memory has Barney, and I'm saying case insensitive in this case, so that means we'll match it with Barney and we'll have Barney as it is without, like, for just the first letter B, capital. The rest is lowercase. Now the lowercase version \L or \U will affect just the next character, like just the first character in the word. Like here Barney, only I want the first letter B to be lowercase, I'll put /L or the lower L, or /U for the first letter to be capital in the string. So in this example, S/ either when you find Fred or Barney, make the memory variable of it, like if I passed by Barney, just the first letter make it capital, so B will be capital, but the rest will stay the same. And with Fred the same, the first letter will be capital and the rest will be lowercase. And here, since I am applying it on any type mix of character by saying I and G, that means repeating. Here I didn't match only the first one, I matched Barney and I matched Fred. Now you can combine them with initial cap. So here what you can do, you can also as well do the following. What I mean here that I can use the \L, which means make all the character lowercase, but I preceded with \U, that means just the first letter capital. So actually it does the same like the previous one, unless I had something different from the beginning than the sentence I have here. I saw Barney was Fred. If I capitalize it, all of it, then the second one, the last one, will be the effective one. So what it does is, one, since I have the G at the end of the sentence, I will, whenever I see Fred or Barney, I am going first \u. I'm gonna make the first letter capital, F or B capital, then I'm saying whatever in that memory, make all the rest lowercase. So the rest of Barney, A-R-N-E-E-Y, will be lowercase. In Fred, R-E-D, the red will be lowercase. Okay, we are done with case shifting. Split function. This is very, very important. Now we are using a function that can be very useful to manipulate text, and this is really important when you want to read data from the input and you know your data are separated maybe by columns, maybe by spaces, maybe by a specific character. So here what we are doing exactly, we are breaking a string by delimiters. We are saying, okay, split separator comma string. This is how the way you have to interpret it. So in the second line or the third line, the example is the following. I have a string ABC colon def colon G colon H, and I want to get out of that string a list of elements. Those elements are splitted by a separator that is colon. So in things, I will end up with the following 4 elements. The first element will be ABC, the second element will be DEF, the third G, the fourth H. Okay. The next example, the adjacent delimiter matches create empty value. Now in this case, since in my string I have ABC colon def colon G colon H, here we'll interpret this is there is no space between the two columns in the middle, but Perl will interpret this like an empty string. So technically the outcome of this operation is 5 elements: ABC, def, empty space, G and H. Okay, so if you want to avoid that, you can put colon plus, which means one or more than one column. So we'll go back to what we saw at the beginning: 4 elements, ABC, def, G and H. Now the before last example, I have colon A, colon B, colon C, colon. What it does actually, if this repetitive separator starts at the beginning of the string, Perl will consider it as an empty space, but anything as a trailing will be ignored. So the output of this would be empty space, then A, actually another empty space, then A, then B, then C, and that's it. Okay, because it considered the age before the first column. Now the very useful way to use this one, if you are reading, for example, from the command line a complete text and then you are putting them inside a list, you are taking only the tokens without the space in between. So as you remember, split is like any other thing that we learned before. If it doesn't have the argument, that means it's working on $_. So here I'm saying, while you are reading the diamond, while you are reading from the input line, do the following: split on spaces, on white spaces it means, since I didn't mention anything else. So whatever white spaces I have, a new line, a tab, etc., is going to put only the tokens, the character inside the words. Let us run this code just to understand more what's going on, and I will explain it more. So here, what I am doing, you have to remember, I will not understand the new line. So first I am reading from the input, and as we know, if I don't mention any character will be in the underscore, in the $_. Then I am jumping, that means I'm taking the new lines, I am putting then whatever I am getting, I am splitting it on white spaces. Whatever I got from the input, I am putting it in a list word. Then what I am saying here, whatever you are taking it, put it in a new list that is the previous list, and which is empty in that case, and the current one. And at the end of the loop, I am printing the result complete. Why I'm doing this? Because actually, as you remember, while will execute on a new line. So what will happen if I just did it? Let us run this one first to show you the difference. So what we are doing here actually, we are just accumulating the words from the input line. So let us run it. Okay, so let's say here is my neighbor, new line. Hello, my neighbor. How are you? Now if I say Control D or Control Z in Windows, as you can see, we extracted all the tokens. Here is my neighbor, hello, my neighbor, how are you, question mark, and all of them became in part of the list named files. Now if I put the print here instead, and I didn't use this accumulator type of list, and just to print it out the word what is in words, so you can see the difference now. Hello, my neighbor, how are you? Okay, and let me stop it. Oh, sorry, I had to put the words here. I was wondering why it's not working. Okay. Okay. So here is my neighbor. Maybe because I changed the sentence. I'm kidding. See, we'll print automatically because, as we remember, the loop works line by line. So we'll print whatever there. We'll go back up to the loop, keep looking. If it's the end of the line, we'll continue looping. So if I say hello, my neighbor, and of course I should put in the print /n to become on the to go to the next line. So we'll print out. So that's why I'm saying that the words list will accumulate what it is in single line. So the other way around, that we put the accumulation inside files, is a better way to accumulate all the text, unless you want to do some work on that specific line. So that's it. I think this is clarify a little bit some of the ideas what split can do for you. Now, the next slide, we're going to talk about join function. Why I'm mentioning join here is not related at all to regular expression, but somehow it does what the opposite of split does. It joins delimiters with text. So here what I'm saying, I have in whole as a scalar, I have join $delimiter, comma, and then I am specifying the list. This is how you interpret it. So in the example, the second line, I have a delimiter colon, and then I have the list, which is here. It shouldn't be a list. It's any list that you can consider it. So, and I separate them by comma. So comma 4, comma 6, comma 8, comma 10, comma 12. So the result will be 4 colon 6 colon 8 colon 10 colon and 12. And it only works between the element. It doesn't add the colon before the 4 or after the 12, so pay attention to that. Now you might not only want to glue all the lists, you just want to add a comma behind the word, like here I have in Word the quoted word Fred, and then I'm saying join comma space at the end of this word. So technically the result would be Fred comma space. Many functionality can be imposed on using join. Just remember it, it's just the opposite of a split, and we're going to use it after a couple of slides. List context. Whatever we did on the scalar with purpose of the substitution, it can be done also in the list context. Now you have to remember, when we used before on the scalar, the output was true or false. Here the output will be the list context. The list will be the list as it is. Okay, so let us see an example to make it more clear. I have in our $_ the following string: hello there neighbor, question mark, exclamation mark. Now I am saying on the left side, as you can see, is a list. How did you know it's a list? Because I have the delimiters as a parenthesis and starting by my, so I have a list. In this list I have 3 elements: the first, the second, and the third. And what I am saying on the right side, I have the following the substitution. I am saying that I have the first whatever the word is appearing, so try to do the following match. Whatever the words are, remember the capital S is the opposite of lowercase, so anything but space. Okay, so I'm saying keep working on the text and break whatever it is until you find a space. After parentheses there is a space. Then keep trying to find another word until you end up with a comma, then space, and then keep working on the rest of the string until you find the following character, the following word. So here what we will end up with, that we have hello in the first, there in the second, and finally we'll have neighbor exclamation mark in the third. So if I print this, we'll have the second, which is there is my neighbor exclamation mark. Why is exclamation mark there? Because it is part of non-space. If I use instead the W, the word, remember the word is only alphanumerical and underscore, so I will not be able to get the exclamation mark with me. If you don't want to get it, then you can use a W instead. Also, we can have a generalization using the /G at the end of our context. So here, for example, give me any bunch of words and follow it by G. That means keep matching until the end of the sentence, until you finish your sentence. So in this case, I'm looking at the same string, the same example, $_ hello there neighbor exclamation mark. I'm saying keep searching for words, and this is really important because it's gonna add them and appending one word after the other, and then we'll add it completely to the list word. So here first we'll find hello, those are words, each character is part of the word. Then find a space, so we'll stop here, there's no word anymore. But since I added the G at the end, it knows that there is another word will match, so it will continue, we'll find the there, and we'll stop by the comma. So now I have 2 elements in my list, hello and there. We'll continue working on neighbor until it stops at the exclamation mark. Then I will have neighbor. So I'll have 3 elements in my list: hello, there, and neighbor. Let us try this one because it's really important, the concept, to understand that how it appends all the words together. Now I have to mention also for you, if you are using those examples, sometimes it is really picky, the Perl. So if you are using a special character, like if I am using the font Courier, the double quotations, they look different, so Perl will not understand it. So try to delete it and write it back. Also, sometimes those spaces will not be understood, so you get error, and you will never understand what kind of error you did over there. Before implementing, I would like to print what is in Word. And the nice about Eclipse, it automatically adds the delimiters twice for you. It knows those are paired delimiters. Hello there neighbor. See, so the list words took whatever is alphanumerical underscore listed in and divided into components. Okay, so this is the array number 1, item 1, array number 2, array. So if I print, for example, print for me, I'm saying 1, just to remind you with what we did with arrays. It's exactly the same, but here we are using the concept or all, just because it is different than other languages. Okay, so here we are getting even more different results. So here what it found, actually the word 1 is there, and actually I made a mistake. I started with 1 instead of 0. So word 0, don't put the comma because will be interpreted in the print word 1, word 3. So if you run this one, you will see exactly the same results. Okay, unless you want to split them with comma in between. Okay, so let us continue on that concept. So this is exactly what we said. This is like a split, but you say what, yeah, in general what you are doing here, you are trying to keep what you want to keep, and you want to discard what you don't care about, like the comma and exclamation mark. Okay, no greedy quantifiers. It's also useful to know, as we notice that Perl is smart enough to start matching from the beginning to the of the sentence to the end. So if I have the following string, Fred and Barney weigh more than just Barney. So, and I am applying the following expression equal delta tilde slash Fred dot star Barney slash, it matched the entire string. So it starts from F, from Fred, and it will continue because I am saying that dot star, that means any character. So technically what Perl does, start from Fred, and then I'm saying all the characters, even that Barney passed the first time, the second time, what it does, it continue to the end until the exclamation mark. Then we'll start back up a little bit. Then it finds Barney, the last one, and we'll say, oh, this is the match. So Fred, then whatever text in between, then Barney. This is how it works. This is the engine of regular expression in Perl. Now, if you don't want this to happen, you want it more efficient, you can tell Perl not to skim to the end of the string, but to move character by character and keep matching. And this can be done by using exclamation mark after the star. So technically what you are saying to Perl, okay, match the first word, which is Fred, then match every character, but keep in mind, if you see Barney in the middle, stop. So here we'll match Fred, and then we'll see Barney, so it's moving one letter at a time, B-A-R-N-E. It found it, then it stopped matching. And actually they added this to the new release of Perl, but they didn't make it like the typical way of matching, because a lot of compatibility and a lot of programmers, they used the previous concept that they didn't want to ruin all those applications written previously. But it's a really smart way to make your program more efficient when you know that you want to match the other word instead of reading the whole text. And where I can see this more useful and really beneficial, let's say you are parsing an HTML file, and as you know, we use /b and /b at the end of delimiter for bold. So you open less than b and then /b greater than. So now you don't really want to get the /b, the one that's listed at the end of your files, because you might have bold characters in all over the place. You really want the one that is just following this one immediately. So this is a very good use to use question marks in that case, because this is what you want the result to be, and not the last one, which is related not to the current match. It is the last match. Multi-line text. Okay, what else? We can actually work on a long text and It's not efficient, but we can save it on string. Here what I am saying, okay, I'm using the function join to get the information for a complete text file, complete, named my handle. If you remember, here we are not using the standard input output, using another file, name it my handle, whatever the name of this file, and I am matching with, there is nothing there, an empty space actually, it's nothing. Instead of putting delimiter, colon, or whatever, I'm just saying I'm gonna match it with nothing, so return will be my file. And I am putting this result in one scalar, string scalar named text. Now I can do something else. I can say, okay, I want the whole string from the beginning to the end. So I can specify the two anchors, the up row, the caret, and at the end of the string the $sign. But you have to remember here, if you are using it on a string, on the file name, the file has a new line, and the new line will not be catched with a caret and the $sign. To fix that problem, you have to add the option M. So this is the last sentence here. So M will embed line in your strings, which is very, very important. The last example down here, what I am saying, okay, match a string at the beginning, start with Wilma. Backslash B, if you remember, at that specific age, that means A will be ending that string. And I'm saying it's case insensitive and will accept embedded lines. That's typically, and do the following. So if this is a match, do the following. Now, updating many files. This is the last slide in this video. This is really, really important. One of the most powerful features in Perl, that you can act on complete files from inside your Perl or even from the command line. So I am splitting it into two divisions. So the second bullet and the third bullet, those are equivalent, and I'm going to explain to you how they are equivalent. So what we are saying here, let me give you the following scenario. Let's say I have a couple of texts in my operating system, in Windows, in Mac, whatever, and I want to substitute the content of each text with new content. So whenever I see, give you an example, let's say I'm writing an email, I want to send that email to hundreds of people, and I just want to change the name that I am listing, keep getting over and over. Let's say in Christmas I'm sending this email to all my friends, and I made it generic, but I am making it more personal by saying, hi John, Merry Christmas, I'm wishing you the best in this year, you and your family and your kids, etc. So I want to substitute John with everyone else that I'm sending the same email. And I wrote this in a file, and I want to have hundreds of files. So how can I make this change happen to all of them at once? Here I'm going to explain it. So first of all, I have the argument var. I'm using it, if you remember it, that's allow you not to have the input from your standard input output, but you can bring the input from files. So the coded word here, I am specifying my files. The stupid things that I am naming my list of files here. It should be file 1, file 2, file 3, file 5, file 6, okay, etc. So I have here about 5 files. I want to make the same change on them, okay? And I'm gonna forget the second line just because this is the most important here and it needs some more explanation. I'm gonna jump to the third line. I'm saying, while I am reading from the line, the diamond here, it means input line. While I am reading from the keyboard, in that case, what you're gonna do, whenever you find the word foo, you're gonna substitute it by bar. So whenever you find John, you're substituted by Christine, for example. And I am saying every time, adding G there, every time you see that word, you have to substitute it, not the first time only. And then I'm saying print, and usually print the standard output, it is a screen. So really this doesn't do what I want to do. The trick is in the second line. When I say $I equal to the string dot back, what it says, This one is gonna make the whole code totally different understood by Perl. Perl will know that no longer you are getting the input from the keyboard, but you're gonna have the input from files that already named in the argument v. So the input now are those files, my list of files here. So this is a bunch of files. So this is the input will be, and the print is no longer print on the screen. It's a print on those files, but substituting the end of those files to dot back. So technically $i does the following. It's gonna take every file in the argument and make a new one and add the dot back at the end. So my dot back, list dot back, of dot back, files dot back, here dot back. So I have completely new, and it's gonna work on this will be the backup, the old file, and it's gonna work on the new files, which is the same name, my list of files here. So it's doing a backup, taking the information from the back, which is the old file, and now substituting whatever you are applying here. So here my string, I am applying a loop, so it knows the loop is gonna work on those files. We'll start reading from whatever string I have in the first file, my, I'm gonna start reading from my.back, and whatever I have word, whenever I have the word foo, will be substituted with bar and saved in file named my, the new one. And we'll continue this to the all files. Very simple. That's it. The last one, it does exactly the same, but you can run it from the command line. What you are doing here, you are saying Perl -p, it means bring a loop while a while loop. This is what it means, from while loop diamond, exactly the same what you saw, and it include the print. So this is -p, it means a print while loop that I'm gonna execute now on what? On the files listed at the end of that argument. So in this case, I have at the end of this argument my list of files here. So it's gonna create a loop to print, and that loop will take the input from my, and it's gonna print in, first of all, we'll make a copy of my and put it in dot back. So we'll create my dot back. We'll take the input from my dot back and read every sentence, and then we'll look at the sentence that I defined it there between two single quotation, s/foo/bar/g. Whenever I see the word foo, I am substituted with bar inside this loop, and I'm printing out not to the screen, but I am printing out to the file, the new one named my. Now the I there is for case insensitive. Okay, the PI, I merged two operations at the same time. So -p while print I, doesn't matter if it's case sensitive or not, if it's upper or lower case, it's case insensitive. I will repeat all this for all the files. The my first, finish, then list, then of files here. That's it. See how much powerful Perl is. By one command line you can change complete files content. Very simple. That's it for regular expressions. We are done now with regular expressions, and we're gonna move to a complete new topic after this. Okay.